All right, so today we're going to talk about simultaneous equations. Which is also called system of equations. So what that is when you have two or more equations that are solved together. And so you have several ways in which you can solve such given equations. You have graphing, substitution, and elimination. So today we're just going to focus on substitution at first. All right, so for substitution, we have a few steps, 4 steps that we complete. So let's just put steps to solve. Steps to solve. And then in brackets, we're going to put substitution. So we know exactly what we're talking about. All right, so your first step is solve one equation for one variable. That's step 1. Step 2 is substitute, okay, spell that right, into the other equation. Okay. Step 3 is then solve. And then step 4 is substitute back. Okay, and so we're going to do some examples, maybe 1 or 2, to cover this type of solving simultaneous equations. All right, so for example 1, the instruction is to solve, S-O-L-V-E. So we have 2 equations, y equals, I was right the first time, 2x plus 1, and then x plus y is equal to 10. All right, so what we're going to do is we're going to substitute the value for y into the second equation. And so what that will look like is x plus 2x plus 1 is equal to 10. Okay, and so we're going to go through and solve this equation like we would any other equation. So that means we're going to do the distribution law. So of course, remember, if there's no number in front of the bracket, the invisible number really is 1. And so x plus 1 times 2x, 2x, 1 times 1 is equal to 10. And then the next step is regroup like terms and simplify. So we want to have numbers with variables on one side, constants on the other side. Is equal to 10 minus 1 because we moved it to the other side and changed the operation. And so we have 3x is equal to 9. And then, of course, we would go ahead and divide both sides by 3. This cancels out. And so x is then equal to 3. All right, and so we have a value for x. So now we would go ahead and then substitute that value into the other equation to solve for y, or to get a value for y. And so what that looks like is, y is equal to 2x plus 1. Y is equal to 2 times 3 plus 1. And so y then is equal to 7. Right? And so our very final answer is going to be, I'll write it here, because what I did not go over is that whenever we solve these equations and we get a value for x and y, the x value always comes first and the y value comes second. And so our answer would then be 3, 7. Okay, so let's just slide it over and let's go over that again. And so again, simultaneous equations is when you solve two or more equations together. And so our steps are solve one equation for one variable, substitute into the other equation, solve, and then substitute back. And so we would have substituted the y equation into the second equation. And so that's how we ended up with x plus open bracket 2x plus 1, okay, is equal to 10. And so we went ahead, we applied the distributive law, and so we got x plus 2x plus 1 is equal to 10. And so we went ahead and we grouped the like terms. So we put variables, numbers with variables on one side, and we put constants on the other side. And so we got x plus 2x is equal to 10 minus 1. Again, because we moved the 1 to the other side. And so because we moved it from one side of the equal sign to the other, we now have to change it to the opposite operation. So because we were adding here, we're now subtracting here. And so we ended up with 3x is equal to 9. And so we want to remove this 3 because, again, we're trying to find the value of x. And so we have x is equal to 3. Fine. We did that, but we don't have the what y is, the value for y. And so we have to go ahead and substitute this value for x into the other equation, just this top one. And so we have y equals 2x plus 1. The value for x that we found was 3. And so we have y equals 2 times 3 plus 1. Y is equal to 7. And again, when we give our final answer, it has to be given in x, y. The x value given first, the y value given second. And so we have the answer is 3, 7. And so let's do one more example. Okay, great. And so let's say now we have, so this is our example number 2. Let's say now we have x is equal to 4y minus 1. And then we have 2x plus 1. Sorry, let me start over. X is equal to 4y minus 1. And then 2x plus y is equal to 13, okay? And so again, our first step would be to substitute. And so we say, okay, we have the value for x. We're going to substitute that into this equation. And so we end up with 2, open bracket, f, y minus 1, close bracket, plus y is equal to 13. So remember, we're only substituting the value for x in, and we leave everything else the same, or we bring everything else down. So we go ahead, we just apply the distributive law. So 2 times 4 is 8. So we have 8y. 2 times minus 1 is minus 2. Plus y is equal to, my little fancy y, 13. So we go ahead and regroup those like terms. And so we end up with 8y plus y is equal to 13 plus 2, because subtraction here, so we're adding here. And so we have 9y is equal to 15. Okay? And so what we do have is, this one is a little bit more complicated than I would like. You wouldn't be given a complicated one like this. Not just yet. And so again, we divide both sides by 9. And so these cross out, and so your y would then be equal to 15 over 9, which simplifies into 5 over 3. And then the next step would then be to substitute it back into the other equation. And so we end up with x is equal to 4 times 5 over 3, close bracket, minus 1. Great. And so we end up with x is equal to 4 times 5 is 20 over 3 minus 1. So remember now, we cannot subtract fractions that have different denominators. So we end up with x is equal to 20 over 3 minus 3 over 3. X is now equal to 17 over 3, and x, you can leave it like that, or of course you can change it to improper fraction. That would be 5 and 2 over 3. If you change this into improper fraction, that would also be 1 and 2 over 3, I do believe. And so our answer would then be the x value first, right? 5 and 2 over 3, and then the y value, 1 and 2 over 3. But keep in mind now, you will not get a question like this because this is too complicated to start off with. It'll only be questions with whole numbers. Okay?